Hello guys, good evening everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, that is the BYJU'S exam prep, and welcome to the MSQ class of Digital Electronics. Yes guys, the time is very near and just trust me that MSQ is going to play a crucial role in the GATE 23 examination, right? All right. Okay. So, I just assume that you might have prepared, you might be prepared, and, you would be looking for MSQ sessions, MSQ practice, because you need really confidence, because kitna bhi concept pada ho. But even whenever you are answering a MSQ question, there will always be little bit element of doubt, and that can only be overcome if you just practice more and more. That's what I believe. Okay, and that is why for subject by subject we are bringing you the MSQ type of sessions. Today is digital, tomorrow will be network, and etc, etc, etc. Miscellaneous sessions will keep running for you, isn't it? Okay, so here all look set. Let's get started then. If all look set, very good evening everyone. Okay, and do not forget to share the session to all your friends. Okay, let everybody get benefited. All GATE aspirants get benefited from this. Okay, chalo guys, so let's move ahead. Okay, this is a brief intro about me in case somebody new to the classes. This is Rakesh. I have secured All India rank 9th in the GATE examination and completed my masters from Indian Institute of Science, Bangalore. And these are the major area of expertise that I've been dealing for more than 20 years. It's working, Raghu. It's working. The same group is working. I just, before coming to the session, just had a post in that. Okay, so guys, this is what, let me once again brief out to you. This is what is the MSQ, Master MSQ series, because this point, it's around almost 20th of January, just around 15 days to 20 days left for your examination. Okay, especially for ECE, IN and CN, just 15 days left. And we believe your syllabus, jitna hona tha. However, it is done now. Only need is test and practice, and especially MSQ practice, because last year the number of MSQs was seen in almost every branch. Next year also we can expect, in fact, a little bit more than the previous year. Right. Now the point is, what are the expected MSQ type questions? Subject to subject we are discussing. What is their approach? And this is live. Okay, and for ECE IN Computer Science, in case you are still not subscribed to the channel, you just have to do one thing: subscribe the channel, so that whether it is MSQ session, MCQ session, mock test session, aptitude session, math session, all of these you will get without any miss. Okay, without any miss. Very good evening all. And guys, this coming Sunday, that is 22nd January at the 12 p.m. Right. If you want to prepare for GATE 2024 and if you want up to 90% scholarship on the GATE preparation programs by BYJU'S exam prep, appear in the scholarship and take your next step towards the success. This test can be obtained on our app. Register for free and appear in this scholarship test. All right. And guys, for GATE 23 aspirants, yes, not studied maths yet, or partially studied. Yes. Digital Electronics is a session for all computer science also. For all branches we have kept it. Okay. So don't worry guys. We will ensure, me and Ankit sir will ensure to give you your 13 marks booster. 13 marks booster in just 2 days. Guys, first, to know all the details about this program and to know the important topics of maths, the approach of maths in the last 20 days, 15 days, you just have to first of all attend this session. This session is tomorrow. This session is tomorrow at 9 p.m. same time. Tomorrow at 9 p.m. on YouTube. Same channel where you are watching this session. We are coming live tomorrow at 9 p.m. on the YouTube. Tomorrow at 9 p.m. on the YouTube, we are coming live. Okay. To give you all details about math, its syllabus, important area, and how we ensure 13 marks. How we ensure 13 marks tomorrow on the same channel. Okay, the same channel, right? Yes, mux and adders can be important from combinational version. Focus more on that. Okay, and then there is this session. Okay, me and Ankit sir and DV Sridhar sir, because I told you this time for computer science, it's going to be discrete maths also. So yes guys, 21st January, 10 a.m. Me and Ankit sir first will come live to cover engineering maths common syllabus of all branches. This is on the app. I will write down the time. Time is already mentioned 10 a.m. But note down, this time, the 21st and 22, 10 a.m. class is on the app. 22nd, 10 a.m. Again, engineering maths, all branches common on the app. Okay. Till evening, we will give the computer science students free. We will set the computer science students free because vector calculus, differential, all this is not in computer science, right? Then, same day evening, 22nd, Sunday. So this is Saturday. This is Sunday. Sunday evening, 6 p.m. There will be the discrete maths for computer science students, but this is going to be on the YouTube only. This is going to be on the YouTube. Discrete math session, same channel YouTube pe rahega, but rest of the topics of maths like, algebra, calculus, probability, vector, differential equation, complex, numerical method, all those things which is common for all branches will be conducted on the BYJU'S exam prep app, right? And how you can log into the app, how you can watch this session, it's free. It's app doesn't mean you have to pay for it. Okay. Right? Yeah, web version of the app will also work. Don't worry. That is why, guys, if you come tomorrow and join us, we will tell you how to join the session, whether you can watch it on the app, how to watch it on the app, how to watch it on the web. Everything we will tell you tomorrow. Okay, so just spare some time. Tomorrow is going to be a very short session. Okay, we'll tell you how this session is going to be conducted, where to join, and important points about mathematics also we will discuss. Okay. Chalo. So let us move ahead then to the first question. Guys, now ready with the question series now. Okay, let's get moving ahead with the question. Number 1, given the number 7f01 base 16, which of the following statement are correct with regard to this number? Radix complement and f's complement. Now, what is the radix of this system? The radix of this system is definitely 16. It is a hexadecimal number. It is a hexadecimal number. So what do I mean by radix complement? Radix complement se matlab hoga 16's complement. 16's complement. And of course, to calculate a 16 complement, we will first calculate the 15's complement. F is the 15's complement. F's complement here can also be known as the 15's complement. So, sir, very simple. Kar dete hain isko fatafat se. Very simple. Right. What is the number? 7f01. How do you calculate f's complement? How do you calculate r minus 1's complement? Subtracting every digit by r minus 1. Subtracting every digit by r minus 1. Subtract करेंगे. So this is f minus 1, which is E, f minus 0, f minus f, f minus 7, 15 minus 7 is 8, and this is known as the f's complement. This is known as 8 not fe. 8 not fe. Option number D. Option number D. Option number D. भाई साहब check करना option number D. Then add 1 to the rightmost digit. Add 1 to the rightmost digit. You get what? You get the 16's complement. So 16's complement, sir. Acha, sorry, ये तो radix का option है. 15's complement is 8 not fe. Sorry, that was C. And 16's complement is 8 not ff. 16's complement is 8 not ff. The answer to this MSQ question is A and C actually. Is that clear to everybody? It is A and C. The answer for this question is A and C. Tick marked on your screen. Tick marked on your screen. Okay. Now for MSQ question. Okay. There is no negative marking. There is no negative marking, but you get full marks. You get full marks if and only if you get both the options correct, like A and C. Now, suppose you come and say, sir, I calculated 15's complement correct, but some mistake in the 16's complement. Will I get half of the marks? Not at all. No partial marking, no negative marking. I repeat, no partial marking and no negative marking. Is that clear, everybody? No partial, no negative mark. Second question. Okay, choose the correct option. The very basic base conversion questions. Okay, we'll go to all categories. We'll talk about combinational circuit, sequential circuit, state diagrams. We'll talk about Boolean logics as well. Okay, let's do it up one by one. So what is this? Choose the correct option. Now, first of all, this is a hexa to octal conversion. Hexa to octal conversion is simple. A7.3b है ना, A7.3b, so I will first convert this to the binary. Converting this to the binary, hexa into binary, every hexadecimal, every hexa. Just stay updated. See, don't ask me number of question and length. I know how much type of question can be there in digital. Okay, that much we will cover. Okay, so let's just take with this. Yes, it is for computer science also, Akash. Okay, so A is 1010, then 7. Every hexadecimal digit to be converted with a 4-digit binary equivalent. Dot 30011 B1011. Now this is binary conversion. Now I need to convert to the octa. Now I need to convert to the octa. Okay, for octa, I will just take up this binary digit and start making groups of 3. How do we make the groups of 3? Okay, starting from the decimal point, decimal se left or right chalte jayenge. Okay, let's go left. 3, 3. Only 2 are left, so 1 will be 0. Then go to the right also. 0, 0, 1, 1, 1, 0. Only 2 are left, so right mein you can add. After decimal point, you can add any number of zeros. Before the number also, you can add any number of zeros. Correct? चलो तो ये कितना हुआ 0102 100 is known as 4 111 is 7 247.001 which is 1 110 is 6 110 is 6 so is it 247.166 sir बढ़िया ये correct है sir A is the correct answer at least A is the correct answer B की बात करते हैं 45.367 but into the binary decimal to binary binary to decimal both are there decimal to binary binary to decimal okay पहले decimal to binary B option पे workout करते हैं तो sir what is that B option okay what is C simple है चलो पहले एक बार C को ना wrap up कर लेते हैं the direct calculations let us wrap up now let's talk about the C option because the integral part is 0 so here also integral part is 0 okay only thing is in the C part 0.1011 in base 2 will be equal to how much this is 0 plus 2 power minus 1 this is the negative position then 0 plus 2 power minus 3 plus 2 power minus 4 right so this is 2 power minus 1 0.5 2 power minus 8 1 by 8 0.625 and then half of this as well 0.3125 0.3125 clear add upon this do you get 0.6 correct 0.625 sorry 0.125 here what is that I have done 0.125 1 by 8 not 5 by 8 okay and then half of this 0.0625 okay 0.0625 just add up and 0.5 6 2 and 8 correct 5 2 7 plus 5 correct that is 0.6875 correct okay so C is also correct C is also correct, sir. Okay, let us just go through the B and D. Now, decimal to base R. Sir, decimal to base R. Okay, decimal to take R. Depends, I Charan. MSQ depends. Sometimes it can be very easy like previous. Sometimes it can be little time taking. 2 marks mil jayega yahan se. If it is time taking, it is time taking for all. Now, decimal to base R, guys. Everybody. Decimal to base R. So, B option pe chalte hain. 45.367. into binary so 45 into binary integral part divide by 2 write down the question and remainder so 45 divided by 2 is 22 remainder is 1 right 22 divided by 2 11 remainder 0 22 by 2 is 11 by 2 is 5 remainder 1 5 by 2 is 2 remainder 1 2 by 2 is 1 remainder 0 1 by 2 question 0 remainder 1 so 1 0 the answer has to be 1 0 1 1 0 1 1 0 1 1 0 1 the integral part has matched what about the fractional part 0.367 into 2 and this is purely under assumption that it's almost 20th January and you are done with the subject you know the concepts okay because if I focus on the concept also in one class okay, then we are able to just maybe discuss 2 or 3 and the session gets over. We want to introduce more variety of MSQ question. We want to give you that feel. But of course, solutions we are discussing, proper solution. Okay, proper solution. So 0.367 multiplied by 2. Multiplication table will come up here and write down the integral part and the fractional part. Right. So 0.367 na, into 2 karenge. So how much? Let's do the calculations part quickly. Okay, let's just keep doing the calculations part quickly. So how much I'm getting? 0.734. Okay. So this is 0 and this is 0.734. Okay. Then again the fractional part 0.734 into 2. Okay. So if I do it into 2, it's 1.468. So 1 and 0.468. Right. Now the fractional part, every time the fractional part multiplied by 2. Every time the fractional part multiplied by 2. Okay. Yeah, JK Paul, Jet Paul, you can. So this is 0.936. So 0 and 0.936. One more calculation if I do, 0.936 multiplied by 2, 1.872. 1.872 and 0.872. Now, etc., etc., etc. Sometimes it doesn't end. Okay, or even if it ends, it's like larger cycle. So it should be 0101, 010111. It's matching up. This much is sufficient. Even up to 4-5 decimal place accuracy is good enough. It is good enough. Okay, so B also looks good. B also has matched for me. Correct. B also has matched for me. Okay. Last is decimal to base 4. Same approach will be there. Decimal to base 4. 2497.5. 2497.5 to be converted to base 4. Right. And this is my option number D. So sir, 2497 divide by 4 first of all. Writing the question and remainder. Okay. Writing the question and remainder. So this is cancelled as 6. Okay. Then you have 0. Then you have 24. You cancel ho gaya 24 se, and remainder will be 1. Remainder will be 1. Then you have 624 divided by 4 again. Keep dividing till you get the 0 question. 0 question. Right? No, Satya, it is going on. It is going on. Just check it out. Even if you want one more or 2 more decimal place, you check it is going to match. Okay. So this becomes how much? 1, and then this is 8, and then this is 1. Okay. So this looks like 181. Okay, 22, sorry, not 181, 1 is 22 to 5 and 24, 156. Okay, there is no remainder, it's divisible by 4, right? 156 when divided by 4. So this is coming out to be 3 and 9. Okay, no remainder. 39 divided by 4. Okay, so that is clearly 9 with the remainder of 3, right? 9 by 4. 2, remainder 1. 1 is less than 4, so 0 question, 1 is the remainder. So 1, 1, reverse में चलेंगे. 1, 1, not 4. Base is 8. Ah, sorry, base of conversion is 8. I read it wrong. Okay, no problem. Sorry. They are asking in octa. Sorry, they are asking in octa. So I'll just have to recorrect this calculation. ये पूरा ही recorrect होगा. No problem, dear. So for octa, let's divide by 8. Okay. Let us just divide by the 8. Yeah. So still the question is 312, remainder equal to 1. 312 when divided by 8. This is clearly 39, 0. Divisible. Okay. Then 39 divided by the 8. Okay. This goes by 4 and remainder is 7. And 4 divided by 8, 0 question 4. So 4701, now check. 4701, yes, integral part matched. Integral part clearly matched. Badhiya. Okay, fractional part. 0.5 into 8, write down the integer and fraction. So 0.5 into 8 is 4 directly, and there is no fractional part, right? And you have to stop when there is 0 fractional part. When there is 0 fractional part. So answer is just equal to, the fractional part answer is only 4. So yeah, this is equal to 4. So this also has matched. A, B, C, D. MSQ question hai na? MSQ question hai. So 1 or 2 or 3 or 4 can be correct. So 4, all 4 are correct, dear. All 4 are the correct, dear. बहुत बढ़िया. All 4 are the correct. Next question की तरफ चलते हैं. All 4 are correct. Choose the correct options. Now Boolean, and I will show you that in the gate 22 there was a question of Boolean and MSQ. वो भी मैं आपको show. I'll present you that question also. Okay, that is why Boolean is one also expected category. Okay, so choose the correct option. Let's do it quickly, guys. A very basic Boolean loss you need to apply here, right? अगर हम A option में चलेंगे, so that is AB plus AC whole bar. Apply the De Morgan's A bar plus C bar. Then, guys, look into this. B bar into B. When you open the bracket, 0 plus A, B bar C. C into C will be just a single C, right? Now see what all terms can be clubbed. A bar plus AB will be A bar plus B. Very, very, very common theorem that is useful in Boolean. Not only in this question, even in the other previous questions of gate, if you see, always remember x plus x bar y, a Boolean variable and its complement multiplied by y. Distributive theorem से आता है ये. This comes up from the distributive theorem. X plus x bar y will be x plus y actually. Right? Because it will be x plus x bar into x plus y. Into x plus y. Yes. So that is simply x plus y. So similarly, a bar plus ab. A is the complement that will get cancelled. A bar plus b. Right? Then आया similarly यहाँ पे इन दोनों को क्लब किया और इन दोनों को क्लब किया. C bar plus C a b bar. तो C bar plus a b bar. Now देखो what is now left? Now we can club this. A bar plus a b bar. It is a bar. A will be absorbed. Right? You're left with b bar. Then plus b plus c bar. Sir, what is b bar plus b? It is 1. 1 plus anything. 1 plus anything is 1. The answer cannot be 0. A doesn't match. A doesn't match. Clear everybody? The answer is 1 plus anything, that is equal to 1. So A is not the correct answer. A is not the correct answer. बहुत बढ़िया guys, keep sharing the session to all your friends. Now we have the option number B. Okay, we have the option number B. Right, option number B में guys Z bar is common to all. Z bar is common to all. Then after taking Z bar common, you look into these terms. Y bar plus wy bar. ये first और last को साथ में लिखा मैंने. And then w bar x bar plus w bar x bar y. ध्यान देना now. This is very simple. Z bar. From the first two terms, dear. From the first two terms, y bar is common. Okay. Y bar into 1 plus w. What is 1 plus w? 1. So no need to write that. Plus w bar x bar. Plus w bar x bar 1 plus y. भाई ऐसे ही करना एग्जाम पे, which you know what is obviously correct. No need to write that step. So 1 plus y is 1. Gone. Remove. Okay. Now you can't simplify anything further. Is it equal to w? Not at any cost. Right. This is not equal to w. The B also wrong. B also wrong. This is not equal to w. The first one is not equal to 0. A and B are wrong. Let's go to the C then. Where is my pointer? Let's go to the C. And the C option is, let me write down once. AB bar plus ABC. AB bar plus ABC whole bar. AB bar plus ABC whole bar plus of A into B plus कितना है बाबा? B plus AB bar. And then what is mentioned? And then there is the whole bar. And this should be equal to 0. Let's match whether this is equal to 0 or not. Everybody, have you tried C and D? Please comment now. Okay, please comment. So here A common, right? ठीक है. And then directly यहाँ से A आएगा. A. ठीक है, no problem. चलो इसको solve कर लेते हैं पूरा. So this is equal to A. Then B bar plus BC. Guys, B bar plus BC, B will be absorbed, though it is only B bar plus C, and then there is the whole bar. This is AB, then that is AB bar. A into A is A, right? Then this is further equal to A bar, after applying the De Morgan's law, it will be A bar plus BC bar, B into C bar. De Morgan's apply kiya, plus A common, B bar plus B will be 1. A common, B bar plus B will be 1, and then whole complement is there. What is A plus A bar? A plus A bar is 1. So 1 plus BC bar, 1 plus anything is 1 and 1 ka complement is 0. This is correct. C is correct, sir. C is the correct at least. Let's talk about D then. D क्या बोलता है? AB whole bar plus A bar plus AB. D क्या बोलता है? AB whole bar plus A bar plus AB and then whole bar. Sir, if you directly combine these two, whether it is AB whole bar, but यहाँ पे भी तो AB, it is x plus x bar. Dear, it is x plus x bar, which is always 1. And 1 plus A bar, that will be 1 and 1 complement is 0. वहां पे भी 0 है. यहाँ पे भी 0 है. तो C and D are correct. C and D are correct. Very easily you can judge from here. The C and D are correct. Very easily you can judge from here. Is that okay, everybody? So correct answer for this MSQ question is the C and D. The correct answer for the MSQ question is C and D. Let's now, this is a Boolean based question. This is still little better. I will show you a variety now. I will show you a variety now. ये देखिए, GATE 2022 MSQ 1 mark, all the 1 mark, but very easy homework for you. ये आप कर लोगे. This is easy. Okay, which of the select the Boolean function which is equivalent to x plus yz. Which of them will be simplified to x plus yz, and this is much simpler than what we have solved. Agar ye aayega, if this comes, this is like almost 2 marks effort. Okay, because little bit good Boolean we have solved in every part. Okay, but previous one, if you solve very simple 1 minute you can get the answer. ठीक है, but homework gate 22 है, homework करेंगे. Let's go to the next question now. Okay, a K-map. Now definitely from K-map MSQ can be there, because number one, why MSQ can be there from K-map? Number one reason is sometimes there can be multiple options of grouping or pairing. Number one reason. Number two, as seen in the question also, they can ask you same SOP and POS. For the same function, they can ask you both. Okay, SOP and POS. That is why from K-map, definitely MSQ can be made. Okay. And even for SOP, there can be both options correct. I don't know. There may be both options correct for SOP also. I don't know. Possibility hota hai na? Let's start this now. With the don't care especially. Summation M135713 plus summation don't care 24681214. Is that okay, everybody? Okay, so चलो आते हैं. पहले हम लोग SOP वाला लेते हैं. Right. Let us first sort out the SOP, and for the SOP, my function can be, okay, my function can be, guys, do it up quickly and just allow me 1 minute. I just need to attend something. Just a minute, है ना? Do it up. Yes, dear. Okay. So hopefully you have tried something. So F is equal to, let me write down, summation of what minterms? 1, 3, 5, 7, 13. 1, 3, 5, 7 and 13. Plus summation of the don't cares. 2, 4, 6, 8. 2, 4, 6, 8, 12, 14. Badhiya. Okay. K-map. Computer organization and architecture. Yes. Superman, it is asked. And guys, just yesterday only, okay, especially for all EC students, we have kept a session on YouTube. For all EC students, we kept a session on the YouTube taken by Satya sir, one of our computer science expert faculties. Okay, that session was exclusively for EC to cover up the COA, the computer organization and architecture, that can be expected in the GATE exam for EC. It has been conducted just yesterday. So you can go through the channel again. And if you have any problems in the computer architecture, you can go through it. Okay, so what is that? It's a function of the Boolean variables A, B, C, D. That this can be A, this is known as the B, this is known as the C, this is known as the D. Now let me fill the minterms. The minterms are 0, 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, 13. And then we have don't cares, which is 2, then 4, 5, 6, 8, 9, 10, 11, 12, 14. These are the don't cares, everybody. These are the don't cares. Now, dhyan dena. Now, please pay attention. Okay. The point here is we need to at least group up all minterms. Okay. This is definitely a quad. Now, there isn't any octa. I don't think there is any octa coming up. No, there isn't any octa coming up. So this is definitely a quad. If it was octa possible, then I will use the don't care. So this is by default quad only. Now this single one is left. What to do with the single one? Okay. Should you pair it up? No, don't cares are in your hand and you use both the don't care, it becomes a quad again. So this is again a quad possibility. Two quads are coming up. Okay. There cannot be a group of 6 now, of course. So what is this? This is A bar above A and D, A bar D, and this quad is in clearly B as well as outside C, the BC bar, A bar D and BC bar, A bar D, BC bar. B is the correct answer. There is only one possibility for SOP. Okay, so A bar D plus BC bar, A bar D plus BC bar. अच्छा, दूसरा वाला भी यहीं पे बना लेते हैं now. Right. So guys, for POS. Now let's turn our attention to POS. POS कैसे निकालेंगे? For POS, either you can follow the grouping of zeros, or I normally go with the F bar. What will be the F bar? See, don't cares are always don't care. Whether you write F or F bar, don't care represent the inputs which is not going to occur. And for the inputs which don't occur, we don't care about the output, whether it is F output or F bar output. We don't care means we don't care. Very simple. Only minterms will change, the missing minterms, right? So 0 आएगा, 1 2 3 4 5 6 7 8 9 कहीं नहीं है, 9 आ गया, then 10, then 11, then 11 also come, 12 13 14 and 15. 0 9 10 11 15 चेक कर लीजिए एक बार, right? Sir, for minterms 2 3 6 7 2 3 6 7, right? 2 3 6 7 you can, but why? You can, but why to unnecessarily create an extra group, Sahiti? You can. Okay, you are talking about this, I think, 2 3 6 7, but why do you need? If you need these two ones will still be left, na? So you again have to make a quad. Unnecessary, you add up, increase a quad. See, important point, you need to group all minterms compulsorily. You don't need to compulsorily group the don't cares. Don't cares can be 1 or 0. So these don't cares are not used. मतलब 0 sir. मतलब 0. ठीक है, तो ये कितना हो गया? ये कितना हो गया? So now F bar is equal to, if I just feed this into the K map na, here, if I feed this into the K map na, acha, directly from this also you can make the K map. No need to write it, but I have written for your clarity so that in future you don't commit any mistake writing down the expression. Okay, as I told you, don't care remains to be don't care, whether it is F or F bar. These are the 6 don't cares. Now 0. ये F bar के लिए लिख रहा हूं मैं 0. Then directly, okay, 9, 10, 11 and 15. देखो, these 4 and 5. Correct. This is what is the plotting. This is what is the plotting. This is again as always A, B, C and the D. Now let us start pairing. Now 1 2 3 4. There is no octa definitely. Okay, but these two one and this one, actually this becomes a quad here. Last row can be taken as a quad, assuming this don't care to be 1. Okay, assuming this don't care to be 1. Now this one left, again 1 1 1 and this don't care is 1, so this is also a quad. Okay, so sir, what is this? This is A B bar, and this particular quad that is in AC. So this is the expression for F bar. F bar is AC and here it is AB bar. So what is F? What is F? A bar plus C bar, A bar plus B. A bar plus C bar, A bar plus B. A bar plus C bar, A bar plus B. No, कुछ और मिस हुआ है क्या? A bar plus C bar, A bar plus C, A bar plus B, C plus D. ऐसा तो नहीं मेरे से मिस हुआ C bar, D bar, C bar, D bar. Oh, sorry. Yeah, actually I missed that. Okay. इसको पेयर करने के लिए either you can take, now there are two options that you can take here. दोनों का सही बोल सकते हैं. No, sorry. I have to just entirely change that. Just that one, I'll erase that. Just that is one. हाँ. So actually ये एक quad हुआ था. I'll just restart it because that one was missed. Okay, that one was missed. Okay, now हाँ, some of you are thinking about octet. Octet लेना है कि नहीं? चलो, think. Even if you take the octet ना, still there will be a problem. Even if you take the octet, okay, these two ones are cleared. Okay, but still ये तो लेना ही पड़ेगा. Okay, ये तो लेना ही पड़ेगा. Okay, this has to be taken, then this is left. Okay, so this quad is anyways going to come. You can't avoid that. Okay, so पहले जो आने वाला है उसको लिख लेते हैं. This is anyways going to come. This is unavoidable. Okay, to pair up this one, okay, you should not take a pair. You should take a group. Okay, now you do whatever you want to do. Okay, now all corners can make a quad. Do you want to make a quad? Or you can make a octa. Now you are free to make a octa because octa will give you least number of terms, right? Yes. Third will be octa. This is outside D, so this is known as D bar. This is known as D bar. This is A B bar, and this is known as C bar. This is known as C bar with A. Sorry, A with C. Okay, so now I will write down once again AC plus AB bar. That portion is same. Okay, but for this one, it's all going perfect. This one for all going perfect. It's octa that is known as D bar. And hence there will be no option that is going to match A bar plus C bar, A bar plus C into D. Yes, we should actually make octa and then only B option is correct, but that is a fundamental of MSQ question. Huh? What is MSQ question? Multiple select question. What does IIT write? What does IIT write? One or more options can be correct. साफ बोलते हैं ना? One or more options can be correct. They clearly tell one or more options can be correct. One or more options can be correct. They clearly tell you. So this is also okay. Only one option correct. Only B. Is that okay? Only B is correct then. Okay, because they have clearly specified minimized. So minimized means we'll take octa. Why we will miss the octa? Right, everybody? So only one option may also be correct in MSQ. One or more option can be correct MSQ. You can read that in the brochure clearly. Not a problem. Let's move ahead towards the next question now. What is the next question? Now, MSQ se one category expected is, of course, the factual questions. Okay, the informative, the factual or the conceptual question, testing your basic understanding. A digital multiplexer can also be used to implement Boolean combinational function. Yes or no? Yes. A multiplexer can implement any Boolean function. We know that. We know that. We know that. With what size? वो भी discuss कर लेंगे अभी हम. चलो, I'll talk about that size also. I'll talk about that size also. देखो, if it is a 2 raised to the power n cross 1 mux, we should know that. If it is a 2 power n cross 1 mux, if it is a 2 power n cross 1 mux, can implement what function? Can implement what function? Can implement what function? A function of how many variables? A function of how many variables? If it has n select lines, it can implement a function of, suppose, n variables. N variables. Number 2 case, it can implement a function of n plus variables also. Right. And number 3, it can implement more than n plus 1 variables also. Condition क्या है? It can implement a function of n variables if used alone. If used alone. That means all the n variables, listen to me orally, all the n variables are fed at the select lines and input lines are fed with either 0 or 1, constant 0 or 1. Right. N plus 1 variables. If n variables go to the select lines, extra 1 variable go to the input line with an additional inverter. Only thing that required will be one inverter. Okay. So n plus 1 variables, if extra inverter used, if only inverter I use extra, it can implement definitely a function of more than n plus 1 variables. More than n plus 1 matlab it can be n plus 2 and n plus 3, anything depending on however gates you want to use, if extra logic gates used. Okay, this you should remember. Is type ke question bante, you should remember this. Okay, clear? If extra logic gates used. So yeah, ultimately they are not asking the size here. Just I added that point. So yes, a digital multiplexer can be used to implement Boolean function. In a combinational circuit, the current output does not depend on the previous output. बिल्कुल वो sequential circuit में होता है. B is also correct. Any combinational circuit can be built using NAND and XOR gates. Using NAND, right, and XOR gates. Any combinational circuit can be built using NAND and NOR gates. ये तो clear है. Can you build a combinational circuit using NAND and XOR? NAND से हो सकता है. Can you do it only using XOR? It's ABD, no. The intent of the question is NAND and XOR. मतलब XOR से भी हो सकता है कि alone XOR. No. Alone XOR not possible. Alone XOR not. NAND. NAND. ABD. ABD. NAND and NOR are the universal gates. Okay. Chalo. Great. Next question here. Okay. Now full adder. Very, very important. Full adder. Okay, which of the following statement is or are correct with respect to full adder? What is the Boolean expression for sum? What is the Boolean expression for carry output? Boolean expression for sum and the Boolean expression for carry output. Yes, guys, tell me. Yes, guys, tell me. Yes, RD की answer RD के answer was ABD, Abraham D. Villiers. बहुत बढ़िया. Tell me, what is the Boolean expression for sum and carry? This must be known to you. And I'm not telling you whether it is minimized or semi-minimized or total expression, but Boolean expression correct होना चाहिए, right? A XOR B XOR C. Tell me. थोड़ा सा ट्रिकी है ये, थोड़ा सा ट्रिकी है ये. I'll tell you why it is tricky. I'll tell you why it is tricky. Okay. I'll tell you why it is tricky. Forget this diagram. इसको छोड़ो, इस पे आ जाओ. When you want to discuss about the full adder ना, when you want to discuss about the full adder, ये diagram का वहां पे कोई role भी नहीं था. Forget. When you want to discuss about the full adder, the sum actually turns out to be summation of the minterms 1, 2, 4, 7, and C out turns out to be summation of the minterms 3, 5, 6, 7. 3, 5, 6, 7, which is also a majority function. Which is also a majority function. I'm telling you, this is little tricky, and I am seeing that in the option. And I'm seeing that in the option. Yeah, many of the answers are not correct. Okay. Okay. अब देखो. Yeah, Prince. देखो. C out की पहले बात कर लेते हैं. C out. Right. If you want to talk about the minimized expression. If you want to talk about the minimized expression from the K map, then it is given by AB plus BC plus AC. That is the minimized expression. If you take it from the K map, you get this, right? Then there is a semi-minimized. Then there is a semi-minimized expression for C out, right? Which is used to build full adder using half adders, and that expression is given by, ये सब हम पढ़ते हैं. This is nothing out of the world. This is very regular things we study with the full adder. A XOR B into C plus AB. How to build a full adder using half adder? It helps in minimizing the delay chains and all. Okay, तो carry के तो दोनों expression सही हैं boss. Okay, let's talk about the sum. Now 1, 2, 4, 7. Right, is A XOR B XOR C. ये भी पता है. A is also correct. Now there is one more option given. A XOR B XOR C. You might be thinking that is 3 input XOR. You might be thinking it is 3 input XOR. इस स्टोरी को यहाँ पे खत्म करते हैं और एक कैलकुलेशन को सॉल्व करते हैं. That is A XOR the B XOR the C. Clear? A XOR B XOR C. Let us solve this. A XOR with the B XOR with the C in. XOR with the C in. ठीक है? What is that? I'll just solve because the very important thing to be discussed. I'll solve and show you once. Okay, कर देते हैं इसको. Okay, A XOR B XOR C in can be written as A XOR B. चलो पहले इसको ले लेते हैं ना. Let's take these two. Okay, तो A XOR B then XOR C in. तो X XOR Y is XY plus X bar Y bar. Okay, now this is equal to A bar B bar plus AB multiplied by C in plus A B bar. A XOR complement will be XOR. So A B bar plus A bar B multiplied by C bar. Sir, if I open na, this is A bar B bar C plus A B C plus A B bar C bar plus A bar B C bar. ध्यान देना, this is 001, 1117, 1004, 0102. This is eventually summation of what minterms? 1247. That is A XOR B XOR C. And hence B is also correct. मैंने बोला था, I was clearly mentioning you, it is tricky. This is tricky. A XOR B XOR C is just as A XOR B XOR C. We never represent 3 input XOR like this. This is not 3 input XOR, okay? This requires a little bit good discussion about XNOR, but अभी उतने time पे नहीं जाएंगे. But what I would like to show you here is that all options A, then the B, AB plus BC plus AC, it is the minimized expression. A XOR B into C plus AB is the semi-minimized expression. That is known as what? That is known as the semi-minimized expression. To implement full adder using half adders. अब इस concept को लेके भी एक question को discuss करते हैं यहाँ पे. Everybody. Let us actually take this diagram here only. Iska need hai next question. So this is the next question. A full adder can be constructed using two half adders and an OR gate. Can be constructed using two half adders and an OR gate. So sir, what is the half adder? What is the half adder? Which gives you the sum expression as A XOR B and which gives you the output as AB. As AB. So look into this. This is one half adder. A XOR B and AB are the two outputs. This is another half adder. अब इसका derivation नहीं कर रहे guys. We absolutely don't have any time and need to derive right now. We have studied enough of theory. Okay. This is also a half adder. Okay. This half adder will give you the first output A XOR B. Next half adder, another has the XOR input. But this time we need A XOR B XOR C. Previous question में revise किया ना full adder. Okay. So here, this next input C in. This is the next input C in here. Clear? So definitely this is producing A XOR B XOR C in. Perfect. Now for carry output, sorry, ये यहाँ पे ना एक mistake है. This is not the correct expression actually. This is not the correct expression. I told you na, for implementation using half adder, we use the semi-minimized. Now please note, what is coming here dear? This is AB. Okay. This is AB. Okay. This comes to the OR gate diagonally. Now we know that this is another half adder unit. What is the input to the half adder? A XOR B. ये यहाँ लिखा. With the next input C. What is the next input? C. Sorry, vice versa लिख दिया मैंने. No problem. This is C and this is A XOR B. What is the output of this AND gate? This AND gate has the output A XOR B to be multiplied by C. Now this is to be added with AB. So A XOR B multiplied by the C plus AB, and this is what is your carry out. That is what I have written in the last question. Na? This is your carry out. So yes, a full adder can be constructed using two half adders and an OR gate, and you must know this diagram. On to this diagram, there have been questions also, previous years based on delays and all. Sridevi, near about 20-30 minutes more, I can say. Okay. So this is what A is correct. Two 4-bit parallel adders can be cascaded to construct 8-bit parallel adder. Yes, yaar. Now this is a 4-bit adder. Suppose I cut this here. थोड़ा छोटा करके समझते हैं इसको. If I cut this here, this becomes a 2-bit parallel adder. 2-bit parallel adder cascaded with 2-bit parallel adder is a 4-bit parallel adder. Similarly, this 4-bit parallel adder, okay, whose carry output can go to the carry input of the another 4-bit parallel adder, it will total become 8-bit. It will total become 8-bit. This is correct. Okay. Carry look ahead adder is used to speed up the parallel operation. Bilkul. The drawback of ripple adder that it is slow. The carry ripple adder has addition time independent of the number of bits. What is the opinion on this? All options correct hai kya? Dear, carry ripple adder has an addition time independent of number of bits. If this is a 4-bit adder, what is the propagation delay of this? What is the worst case delay of this? It is given by the formula n-1 TC plus max of TC TS. You know this formula? n-1 TC. TC is the carry delay of one full adder. TS is the sum delay of one full adder, and the total delay, worst case delay, is given by n-1 TC plus max of TC TS. n-1 TC plus max of TC TS. And definitely the delay depends on number of bits. More the number of bits, more slower will be the ripple adder. And carry look ahead adder has the advantage in terms of speed, but it has a complex hardware. Bhai, you need more speed to pay more. Paisa dena padega, simple. Carry look ahead adder is complex design. Okay, it is more costlier, but it will offer you better speeds because it breaks the carry weight cycle. Okay, it doesn't depend on the rippling action of carry. It generates the carry of every stage by a separate hardware block. ज्यादा से ज्यादा हार्डवेयर हो जाएगा वहां पे, but it will give you a better speed. So D option is also correct. Carry look adder is used to speed up. Okay, but this is wrong. It is not independent of the number of bits. It depends on the n. The maximum delay n minus 1 TC plus max TC TS. I repeat, if you don't know, you can write down TC and TS are the carry and sum delay of a single full adder. Of a single full adder. ठीक है जी. So ACD is the very correct answer. ACD sir is the very correct answer. चलते हैं अगले क्वेश्चन की जर्नी पे. Okay, let's talk about the next question. Synchronous counter reduces the delay time of a counter to the delay of a single flip-flop and a gate. Yes or no? Yes, that is what MSQs will actually involve conceptual discussions. Numerical तो होगा ही. That is where MSQs are tricky. There can be numerical discussions as well as conceptual discussion in the same question. Okay, mod 10 counter is also referred to as a decade counter. चलो जो समझ में आ रहा है उसको तो टिक कर देते हैं. Yes, all my PDFs password protected. I will share you the PDF of this. Okay, but that will be password protected. अगला आ जाते हैं. An asynchronous decade counter increases the value by 10 for each clock. नहीं भाई, decade counter is one. जो B option में बोला है. Decade counter is one which counts one decade. It will count a sequence of 10 states. Okay, it is a mod 10 counter. Okay, it doesn't increases by 10. C तो wrong है. अभी A पे डिस्कशन नहीं किया है मैंने. C तो wrong है. The modulus of a counter is same as its maximum count. D. The modulus of a counter is same as its maximum count. भाई, there can be a counter counting 0, 1, 2, 3, 4, 5, 6, 7. Okay. That is mod 8, right? There can be a counter only counting odd numbers. 1, 3, 5, 7. Odd number counter. Right? This is a binary counter. There can be a binary counter. There can be odd number counter. बोलिए. Right? How many states does it count? It is mod 4. Mod is the modulus of a counter, number of states it can count. But what is the highest count? 7. So D is definitely wrong. Modulus is not same as the maximum count. Modulus is different. Modulus is the number of states that the counter cycles. Okay. Okay. Cycles. Superman, I'm not exactly able to recall. Maybe I'll just check and confirm. I'm not able to recall 100%, but it can be a possibility. I'm not sure at the moment. I can check and respond to you, but possibility है. मतलब पहले नहीं आया उससे ये कोई मतलब नहीं होगा. ठीक है? Now A option is left. Synchronous construction reduces the delay time of a counter to a delay of single flip-flop, and if there is extra gate, definitely yes. Definitely yes, because that is what is the meaning of synchronous counter. Dear, what is a synchronous counter? नहीं, A तो correct है रवि तेजा. What is a synchronous counter? All the flip-flops are clogged. All the flip-flops are clogged through a common clock. All the flip-flops are clogged through a common clock. Through a common clock. Okay. All the flip-flops are clogged through a common clock. All the flip-flops are clogged by the common clock. Okay, this is what is the design of 3-bit binary up synchronous counter. Synchronous counter. Chalo, with this first and last flip-flop, there is no gate. But suppose when you send the clock to the second one, what is the delay? Okay, what is the delay such that the output of this flip-flop reaches the next T input? So there will be the delay of the flip-flop plus the delay of the gate. Okay, but when the first flip-flop has computed, sorry, when the central flip-flop has computed the calculation, third and first are also completed the calculation because they received the clock at the same time. Synchronous counter. Synchronous counter. Clear? That is what is a synchronous counter. That is what is a synchronous counter. So the total delay, the propagation delay is actually given by, right, the delay of a single flip-flop, right, plus the delay of the AND gate, or this is also approximately T flip-flop. If it is a very minute combinational circuit, the delay is negligible. It is almost negligible in front of flip-flop, and we can also call it as TFF only. Clear? So TPD approximately equal to TFF. Approximately equal to TFF, that also works. But if it is a ripple counter, dear, let's not draw the diagram. या चलो एक diagram बता देता हूँ, थोड़ा सा revise हो जाएगा. If it is a 3-bit ripple up counter, or in general, formula in general का रखेंगे. Let me show you a 3-bit ripple up counter. Right, this is T0. For a ripple counter, all the flip-flops are in the toggle mode. So there is no extra combinational circuitry required for the inputs. All the flip-flops are in the toggle mode. That is, all the T inputs are 1, 1 and 1. All the T inputs are 1, 1 and 1. Okay. And for up counter banana hai, so let me use the negative triggering here. Clear, everybody? Okay. And the output, or sorry, what have I done? Ripple counter बना रहे ना, sorry, just a moment. Clear, everybody? Okay, this is what it can be. Okay, now what is the TPD here? The TPD here will be, suppose you give the clock at t equal to 0. Isn't it? Suppose you give the clock at t equal to 0, right? Then there will be a delay of the first flip-flop, then only next can trigger. Then the triggering of this, the transition on this will decide the triggering. Suppose this also makes a negative transition, so third flip-flop will trigger and it will again take the time of TFF. So total time will be 3 TFF. Total time will be in general is NTFF. Clear, everybody? Total time will be NTFF. Okay, it will be more for a ripple counter. So option number A is also correct here. For a synchronous counter, it reduces the delay of a counter to delay of a single flip-flop and a gate. But the delay of a gate can be negligible also. But the option number A is generally correct. Option number A is generally correct. Now you have to tell me the next answer here. If you have understood this, answer me next. Just in a moment, I'll be back. Yes, guys. Chalo, let's answer this. The input clock frequency of 60 megahertz is given to a cascaded combination of mod 5 and mod 15 counter. Output frequency will be 3. Now, two counters are cascaded, the mod numbers are multiplied. Okay, cascaded combination. Okay, so what is the final modulus of the cascaded combination? It is 5 into 15, that is 75. Please note down if you don't know. Two counters are cascaded, then their mod numbers will be multiplied. So the final mod is 75. Okay. Then, sir, what is the output frequency? Then that output frequency will be equal to the clock frequency divided by 75. clock frequency, that is 60 divided by 75, that is not equal to 3. So A is not correct, everybody. A is not correct. Okay, 3 तो नहीं है, ठीक है. The maximum clock frequency that can be used for an n-stage ripple counter. Yes, guys. Okay, minimum लिख दिया क्या यहाँ पे? Then this is wrong. TPD is the propagation delay of each stage, like TFF already I told you. So what is the total delay of ripple counter? NTFF, NTPD. यहाँ पे TPD is the delay of each stage. So what is the total propagation delay of ripple counter? NTPD. Then that will decide the minimum clock period. That will decide what? Minimum clock period. Here you send the clock. Listen, the idea is the first clock edge is applied at t equal to 0. यहाँ समझना है इसको. Okay. Let's say the first clock edge comes at t equal to 0. Okay. Negative edge triggered है ना? Negative edge ले लेते हैं. चलो, no problem. Okay. The first clock edge comes at t equal to 0. The next comes at t equal to t, and we call this as the time period. We call this as the time period. But we know that for successful completion, for successful transition of the state, this needs a time of NTFF. So what should be, dear, what should be the minimum value of this clock period? When will you expect the next transition? Before a first transition is successfully complete. Okay. And for the successful completion of one transfer, I need 3FF time. So this T should be greater than 3. या तो N लिख देते हैं in general. This T should be greater than or equal to NTFF. So what is the minimum time period of the clock? Let me call it as T clock. Let me call it as T clock. Okay. So from here we get the concept of the minimum time period of the clock, and that is NTFF. So what is the maximum clock frequency? What is the maximum clock frequency? Is 1 upon this time period. Time period minimum, so clock frequency maximum. So this is the maximum. Minimum nahi, ye maximum hota to correct hota. Right now it is wrong, sir. Right now it is wrong. Okay. The propagation delay of the flip-flop in a ripple counter does not import a limit on the frequency at which counter can be clocked. Wrong ho gaya na? Sir, wrong ho gaya. The propagation delay of a flip-flop does not impose a limit on the frequency at which the counter can be clocked. The frequency at which the counter can be clocked is decided by 1 upon TFF. This is the maximum. Frequency will be less than 1 upon TFF. TFF is the delay of a single stage flip-flop. And yes, that decides, that is there as a factor. So this is wrong. C wrong. In a 4-stage ripple counter, propagation, yellow here, D numerical hai yaar. D is numerical. Okay. They are asking maximum frequency for which? For the reliable operation. The maximum frequency for the reliable operation. Okay. And T clock max, all that we discussed, na, that is coming up here. T clock max is equal to 1 upon NTPD. N kitna hai? 4 stage hai. And TPD for a single stage, single flip-flop delay 30 nanoseconds, 30 into 10 power minus 9. हमें चाहिए megahertz में. So 10 power 9 ऊपर गया तो 10 power 3 into 10 power 6 divided by 120. Sir, what is 1000 by 120? Yes, it will be 8.33 only. Correct है ना? Yeah, बिल्कुल सही. So that is known as 8.33. 10 power 6 is mega. So answer is 8.33 megahertz. D is the correct. And this is second instance for today where only one option is correct. That is possible means possible. MSQ, one or more than one option can be correct. One or more than one option can be correct. Yeah. Typo error tha. Please neglect that. F clock maximum. Okay, Prince? Yeah. ठीक है जी? Done, sir. D is the correct answer. D is the correct answer. Let's move ahead towards the next question. Here it is. The output of this is considered as Q3, Q2, Q1. Okay, that means MSB बता दिया आपको. Output is considered as Q3, Q2, Q1. So this has to be the MSB. This has to be the LSB. And initially all the flip-flops are in rest. Rest नहीं होता है. Reset होता है. Typo error होगा ये. That is the reset condition. Okay. अरे बाबा, which of these is false? क्या Superman? एक सेकंड, शायद वो मिस्टेक हुआ क्या? Oh, which of these is false? Sorry, है ना? In order to speeden up, I am just covering more and more questions within this limited 1.5 hours. Okay, so A, B, and C, these are false. Okay, this is not equal to 3, so false. Okay, this is also false. Right, this is also false. This is the only option which has given the correct answer, A, B, C. ABC. ABC. Superman, correct. ठीक है, ABC as per the MSQ question, which of the statement is or are false, ये ध्यान देना था, that is the ABC. And be very careful MSQ में, है ना, false or true, false or true. Right now I am in a hurry to take more and more question. समझ पूरा रहे, but just to cover more question, I think I read it as true. No problem. Next one. हाँ, we are here. Which of the option is correct? Which of the option is or are correct? True ही निकालना है. Okay. What is the count sequence? What is the modulus number? Whether it has a lockout problem or not. Let us try to understand that. Okay. Now, if you want, it's a synchronous design only. All the flip-flops are getting the common clock. And if you want, you can start, okay, by the count sequence as you see in the picture. Normally, when you reverse na Q3, Q2, Q1, sometimes students confuse. I have seen that. So better write down Q1, Q2, Q3. Last में we can invert it. Last में we can reverse it. Okay. So Q1, Q2, Q3. आ जाते हैं यहाँ पे. Initially they are reset. Initially they are reset. Okay, Q1 goes here, Q2 goes here, perfect, and Q2 bar comes to the T1. Okay, so one by one, everybody, just keep noticing that. Oh, this is now 1. All are initially 0. Okay, so its complement goes 1 there. This is 0, this is 0. So guys, T1 gets a 1. And what is the T flip-flop functionality? If input is 1, there will be toggle. If input is 0, there is no toggle. The same state. So T1 input is 1. Q1 will toggle, rest of the two inputs were 0, so they remain in the same state. And now let us change the conditions. So what is the state of the counter now? 1, 0, 0, right? So 0 complement 1 comes here. ये तो 1 है और ये 0 है. Is that clear everybody? Okay, so T1 is 1 again. T1 is 1, so toggle. What is T2? That is also 1, toggle. Okay, and T3 is 0, no change. Just a moment. Wait, कुछ तो issue हुआ है. हाँ. So we have written 0, 1, 0. Now next, let me repeat that 0, 1, 0 here. So we have got now 0, 1, 0. So its complement is 0. So T1 input is 0. T2 input is also 0. T3 is 1. This time only T3 input is 1. Only T3 is 1. This will toggle. Remaining two in the same state. So 0, 1, 1. 0, 1, 1. यहाँ लिख देंगे 0, 1, 1 now. 0, 1, 1. Okay, so 1 का complement 0. T1 input is 0. T2 input is 0. T3 is 1. Again, T1 is 1. T1 is 0. 0, 1, 1 था ना? Correct. हाँ. So T3 is 1. So 0, no change. No change. This is 1 तो toggle 0, 1, 0 पे आ गए. तो next is 0, 1, 0. Clear everybody? Okay. तो यहाँ पे तो lockout आ रहा है. There's a possibility of lockout. Okay. Sahiti, when Q1 is toggled and becomes 1, Q2 also changes. No, it's a synchronous counter, Sahiti. Right. First, to decide the entire state. Okay. One particular state change you don't affect in the same case only. Then that will be affected in the next cycle. Next head here. Next क्या है? 0, 1, 0. 0, 1, 0. This is toggle to 0 now. 1 का complement 0. 0 comes here. This is 0. This is 1. This is 0. No change. Right, this is again 0, no change, but this is 1, toggle. Now it is in the lockout. After 100 कुछ बोल रहे हैं क्या आप लोग? एक बार चेक करते हैं, just wait है ना. After 100, if you are telling 1, 0, 0, 0 complement 1, this 1 comes up here, 1 comes up here, 0. So 1 means toggle, right? 1 means toggle, 0 means no change. सही तो है dear. Where is the problem? नहीं, how it is 1, 1, 0? The T1 input is 1. 1 means toggle, na? After 100, it is all going correct only. It is correct, guys. Don't be confused. I have again shown you. It is all correct. Okay. And we identified lockout also. चलो, तो फिर से देख लेंगे. कोई issue नहीं है. Okay, so now we are at the state 0, 1, 0. So this toggle will be 0. Okay, now T1 input is 0, T2 input is 0. This is 1. Input 0, input 0. 0 input means no change. Okay, this is 1 input. So this will toggle. Last one will toggle. Again, I will write down now the state. That is 0, 1, 1. 1 का complement 0. तो T1 input 0, T2 input 0, T3 1. तो भाई 0 input no change, 0 input no change, 1 input toggle. So this is lockout problem. This is definitely a lockout problem, right? So this counter has lockout. This counter has lockout. So we need to try something else now. Okay. At 2 and 7, this is stuck. Okay. So 0, 2, 0, 4, 2, 7, but then it locks at this stage. It just locks at 7 ke baad 2, 2 ke baad 7, right? So even if we start with 0, it finally enters into the lockout state. Ab aa jate hai. Let us try here now. Sir, Q1, Q2, Q3. What is not coming up here, sir? 0, 0, 1. Let me try 0, 0, 1 now. Let us say the counter is 0, 0, 1. Without that, I can't commit the mod number. So 0, 0, 1. Okay. The output is 0, 0, 1. So this 0 complement 1. So T1 input 1, T2 input 0, T3 input 0. T1 is 1. Isko toggle karenge. Rest 2 inputs are 0. So no change. I go to 5. Right. So guys, now let us write here 1, 0, 1. 1, 0, 1. Clear? ठीक है 1 0 1 this 0 का complement 1 तो T1 input is 1 T2 is 1 T3 is 0 पहले दो input 1 है तो first two will toggle last input is 0 it will remain to be same it will remain to same okay then 0 1 1 you know what will happen so again lockout so it has lockout problem only it has lockout problem only ये lockout ही चलेगा ये lockout ही चलेगा it has lockout problems only okay so now can I say its count is 0 4 no 0 4 3 तो नहीं आया right 0 4 2 this is wrong 0 3 no this is wrong it has only lockout problem does it have any modulus number चलो एक बार फिर भी verify करने के लिए I'll just try the remaining two combination I'll try the remaining two combination. What are the remaining two combinations? 0 हो गया है. We are done with 0, 4, 2, 7. Okay, we are done with 1 and 5. So what is only left? 6. And 3 कहीं नहीं आया ना अभी तक. नहीं, this was 3 only. This was 3 only. 7 has not actually come. So we are left with only 6 and 7. We are only left with 6 and 7. Does something good happen with the 6 and 7? Does something good happen with 6 and 7? चलो वो भी यहीं check कर लेते हैं. 1 1 0. I'll show you everything about this. Right? 1 1 0. Right? 1 का complement 0. This input is 0. Right? So no change. T2 is 1. तो toggle. T3 is also 1. तो toggle. 5 आ गया. चलो बहुत बढ़िया. ये आ गया 5. 1 0 1. This becomes 1. This goes 1. T1 these two are 1 तो इन दोनों को टॉगल कर दिया T3 इनपुट 0 नो चेंज भैया घूम फिर के वो 3 पे जा रहा है नहीं for mod 2 why it is not a mod 2 counter it is a waste right waste why it is waste for mod 2 counter why do you need 3 flip-flops so it only has lockout problem dear it only and only has lockout problem so 0 1 1 आ गया sorry 0 1 1 आ गया तो again locked. Is that clear to everybody? And remember it can't be mod 2 because mod 2 simply means why do you need 3 flip-flops? Mod 2 can be designed only using 2 flip-flops. Or mod 2 can be designed using a single flip-flop only. Then it is a waste design, wasting 3 flip-flops. Clear everybody? Is that clear everybody? Right. Which of the following capabilities are involved in a universal shift register? Which of the following capabilities are involved in a universal shift register? Tell me. Can it do shift left? Yes. Can it do shift right? Yes. Can it do parallel load? Yes. Can it add serially? No. It is not a serial adder eventually. Na? For serial adder, you need some more components with the shift register. A, B, C. The correct answer is A, B, C, sir. The correct answer is A, B, and C. The correct answer is A, B, and C. ठीक है चलो one more 2022 MSQ question based on state diagram. A state transition diagram with the states A, B, C and the transition probability P1, P2, P3 up to P7 is shown in the figure. For this state diagram, select the statement which is or are universally true. Statements which is or are universally true. बहुत लोगों को लगा ये क्या ऊटपटांग क्वेश्चन आ गया, व्हाट इज दिस रैंडम? इट्स अ वेरी लॉजिकल क्वेश्चन. इट इज वन ऑफ द वेरी लॉजिकल क्वेश्चन. इवन इफ यू डोंट नो मच अबाउट स्टेट डायग्राम, थोड़ा भी पता है ना स्टेट डायग्राम शोज द ट्रांजिशन ऑफ स्टेट्स, you should be able to handle. Looks like a difficult, one of the easiest. Why? Because it's an aptitude. Actually digital nahi, it's an actual aptitude question. How it is aptitude question? Right, guys, what are the transitions from state A? What are the possibilities from A? Dear, what are the possibilities from the state A? That if currently you are in state A, either you will remain in same state, either you will make a transition to B, either you will make a transition to C. यही तो होगा ना. Anything else can happen. If you are in state A, either you will remain in same state with the probability P7, either you will go to B, probability P1, or either you will go to C with probability P4. This is the list of all possible outcome and sum of all probabilities. Sum of all probabilities always equal to 1. Batao. Similarly, if I want to talk next with respect to state B, it can be B to A, it can be B to B, it can be B to C. Right. Similarly, from state C, you can be going from C to A or C to B, or you can remain in same state C. What is the transition probability? It is shown in the question. So B to A probability P3, B to B P2, B to C P5. नहीं, B to C नहीं है, B to B P2 है, B to A P3 है. From B to C there is no transition. Because there is no transition, it is 0. P2 plus P3 equal to 1. Sum of all probability 1. C to A जा रहा है P6 probability. C to B, there is no transition from C to B. That means there is no probability. B to C possible नहीं है ना. That is what I use. That is why it is taken as 0 probability. Impossible event, 0 probability. Then sir, C to C, P5 probability. Sum of all probabilities, P5 plus P6 equal to the 1. Sum of all probabilities, P5 plus P6 equal to 1. तो P2 plus, अब देखो ऑप्शन क्या क्या है, P1 plus P4 plus P5 equal to the 1, right? And P2 plus P3 is same as P5 plus P6 is same as 1. Correct answer is A and C. Two options are correct here. Two options are correct here. Yeah, two options are correct. Answer is A and C. Superman, yeah, that's what. B to C not possible. That is what I've written. B to C not possible. That is why 0 probability. Impossible likha hai na. You know why I discuss here? Rest of the questions were not MSQ. I have shown you two MSQs. One was very simple. That was Boolean. And this is the next next PYQ. MSQs to sare discuss kiye. I'm sorry. We have discussed MSQs, out of which two PYQs I have shown. One was very simple Boolean. वो तो homework दिया है आपको. Why I discuss this? Just to give you the confidence कि sometimes abrupt language can be there. अरे यार probability, वैसे probability से भी डर लगता है, state diagram से भी डर लगता है, तो कैसे करेंगे? One of the very logical and aptitude based question of digital. I'll tell you. You decide whether solving this question is easy. You decide now whether solving this question is easy or whether solving this question is easy. You only decide and answer in your heart. Answer in your heart, isn't it? Chalo guys, that's it. See you tomorrow 9 p.m. Same channel YouTube. We will talk about detailed discussion of math schedule. Tomorrow at 9 p.m. me and Ankit sir on the YouTube. On the YouTube. I'll actually share you the link of the YouTube. It will be better. I'll share you the YouTube link so that you join it up without any particular specific problem. Tomorrow at 9 p.m. to reveal you everything about how we are going to cover up the maths for you. What is the importance of it? What is the subject wise or chapter wise importance of maths? This is the link for tomorrow's class. Open up, set the reminder. मैं telegram में भी share करूंगा. Set the reminder, start liking it, like aptitude, let this maths be a big hit as well. So start liking it immediately. Okay, and tomorrow will be the next MSQ class. Okay, And this is the entire detail of maths. Okay, but tomorrow we will tell you what all will be covered, how it will be covered, how it can give you the benefit, how to join the session on app, how to join the session on YouTube. Everything will be told tomorrow. Okay, so tomorrow you must join because it's a very small session at 9 p.m. but very important for you. Link मैंने share किया, share, like करो और channel को subscribe करते जाओ. And guys, tomorrow MSQ session will be, one more update. Tomorrow MSQ session will be network theory. That is at 11 a.m. Clear? Okay, Ashu sir. Ashu Jhangra sir, 11 a.m. network theory MSQ. MSQs from network theory. Next very important subject. But that is tomorrow at 11 a.m. on the same channel. Bye bye. Good night. Stay safe and take care of yourself.